Now the interesting thing is how to train the SVM. So try and catch is usual, just to, if we have any problem, message box.show ex.message, and here we will create an object for SVM equals new SVM, and we need to put some configurations for this SVM, like svm.c, that is the cost that I want to apply is 100 during the training, and svm.type I want to use is svm.type. I want to use the classification and classification. Since we have 10 classes, so I'll be using CSVM, the classification, and also we need to do SVM dot, we need to define the gamma. This is how the learning will be done. It will be 005, let's say, and these are the things which you can try yourself according to your needs and according to your results. Let me select the kernel to be use a simple linear kernel for me, and then also svm dot termination criteria is equals to, let me select the 1000 iterations, and epsilon that I want is exponential -6, and finally I can use the svm dot train function, and this one requires, as you can see, the samples that we have, that is the train data that I have created, and data layout, how your data is layouted, that is I have the samples in rows, so I need to select this raw sample, and also we have the train labels for it. So that's it. So I pass the training data and how my data is layout and the training labels. So this will train the SVM. And optionally, one interesting thing is you can save the results svm.save. You can save anywhere. I call it svm.text. So next time you don't need to train it again if you have already trained it. This is just will create train my SVM, and once the SVM is trained, I need to test it. First I need to make sure that I have the test data. It's not if equals null, I should return. I don't need to do anything, and then I can put a try catch block and message box ex.message, that's okay. And what I need to do, that to test the SVM, I have the test data in my test data matrix. I need to loop through this matrix one by one. I will select the row and pass it into the SVM for prediction. I will display I will create a counter. I just call it counter equals 0. This is not the global one, this is with the small, so this is a different count. And if I shouldn't use this if here, or rather I should also make sure that if svm equals null, again I should return. I have, if svm is not trained, I will also not do anything. So if we reach here, it means we have both the test data and also the SVM is trained till now. So let me apply a for loop till test data dot rows. I will create a matrix of floats and I call it raw, and from test data I read each row, get row one by one, and once I read the row, and now I need to pass it into SVM for testing. So float predict equals whatever the prediction it has for me, svm dot predict, and give me prediction for this row. In the label test dot text, I can display input label, that what was my input label, that I can get it from test label, and the raw is I and 0th dot to string. This is the test label I display in the test, and similarly I can display the output label dot text equals to the predicted label plus predict dot to string. So just I want to visualize whether what was my input label and what is the predicted label. And also if the predicted label equals to test label of I comma 0, then I should say that counter plus equals 1. So it is a correct prediction. And if a user wants to see the current image of the data, digit is display equals true, then I need to convert this image into a label just like this. I just copy these two lines and paste it right over here, and instead of this train data we have the test data. And I also, since it is a user interface, I want to display the user interface, I need to do this async, and right over here I can say that await task dot delay for, let's say, 1 second, else we will wait for, let's say, task dot delay for 1 millisecond to display the label in the user interface. And once the for loop is finished, that is, it has processed all of it, we can display the accuracy in label accuracy dot text equals to, and to find the accuracy we will do something like accuracy equals, what we need to do is to divide this counter by the size of this test data dot rows, how many rows we had, and maybe I need to convert this one into float so that it shouldn't make problem for the integer division. So let us run this application and test it. The first thing that I need to do is to load data. So it display the image that data is loaded. We can check this image. For example, you can see 5. There is some problem. Just go and click on this. This one should be less than data, then I need to increase the counter. Similarly for this one, if counter is greater than or equal to 0, then I need to reduce it. Okay, load data. Okay, and now we can see this data here, 0, 4. This is the image that we are taking as input. One more thing that I need to do is, just after finishing the training, it should display a message box, SVM is trained. And after the testing, it will be displayed like this. Maybe one more thing that I need to do is this is display equals to true, or I should say checkbox. What is the name of this checkbox, by the way? The name of this checkbox is CB show data, checkbox show data dot checked. Whatever the status it has, we will assign it to this one. And let's start it again. File load data. Okay, and now we can train SVM. It will display a message once it is trained on the data. Okay, and let's test the SVM. So show it is 7, so it can show this 8. It is not actually updating it. It is not updating the image, but you can say this input label is 5, the predicted is also, you can see that over here. I'll show why it is not updating this image. Let's see the accuracy first. So on this test and train data, it gave me an accuracy of 91% using this SVM. The most important thing that you need to note over here is these parameters. If you change, for example, we can have multiple options. We can use the regression problem or one class SVM or with the epsilon. It is a matter of tweaking around these parameters. For example, I used a linear SVM, but when I tested with this RBF kernel, it didn't give me good results for the same data. But when I used this linear kernel, it produced optimal results. And also I have hard coded these values for the gamma and the cost parameter. So in a real practical application, we usually search for these parameters in a predefined range and find those optimal parameters, and using those optimal parameters we train this SVM. And once we have the SVM, I have saved this svm.txt, which we can see from here in bin folder debug. I'll open it externally. So here you can see an svm.txt, and this is what the structure of the svm.txt I have. Next time I don't even need to do these things again. I can load this svm.txt directly. So how can we do that is to, let me show you here. So if a file that exists, I just call it and put it in the debug, as you know, svm.txt if it exists. So what I can do here is svm equals, I create a new object of this svm, and then there is a special class file storage, file new file storage, and here I will pass the name of the file svm.txt, and what I want to do is file storage mode I want to read that file. Sorry, file storage, I wrongly written it as file string. Now I can read the parameters from svm.read and file.get node. Which node I want to read is, here we have the node. This is the OpenCL_M_SVM, this node, and I want to load it into the SVM. In this case, I don't need to do all of these. What I will do here is it will be in a part of else. If I don't have already trained SVM, then I should go for training it and save it as SVM. So you have to save it. If you want to save somewhere else, you have to give the path. Since I have not given any path, so it will save it in my debug folder, as you can see here. So let's test it. Let me put a breakpoint over here and run it. File or load data, and I don't need to do that. Let me stop it, run it again, and SVM train data. So let's step into it. So it found it, and then now the SVM is basically loaded all the, as you can see, C, the gamma, and whatever we had set in the previous run is available over here. So it will give us a message SVM is trained, and then we can test for the data. Since I have not loaded the data, so you can try around the different parameters, and I hope this video will be helpful for you, and see you in the next video.